Hello, in this video I'm going to be going over a parametric equation that has a bit of differentiation, maximums and mins, and a little bit of parametric integration with it as well, and then finishes off with integration by parts. I think to my mind it's the only time I've seen that they've had the parametric formula come up for integration. But yeah, anyway, let's just get on with it. So we're given a parametric equation here, and we're told to find this maximum point P here, which involves finding differentiating. So I want to differentiate these two, or at least I'm definitely going to need to differentiate this one and set that equal to 0 to find the maximum or minimum. Let's do that first, and then talk about whether we need to differentiate this or not after that. So we've got y equals to t cubed e to the minus 2t. It's a product, so we're going to need to use the product rule. So we've got u is equal to t cubed. So du by dt, or u dash, is equal to 3t squared. And v is equal to e to the minus 2t. That differentiated, well, it's basically we've got the minus 2 there, so that's e to the minus 2, e to the minus 2t. Basically differentiating e to the x, like kind of very simple chain rule type thing. E to the kx differentiates to k e to the kx. So we can do the product rule on that to get dy by dt. Cross multiply and add. So dy by dt is equal to minus 2t cubed times e to the minus 2t. That's that bit there. And then plus these two multiplied by each other here. So that's 3t squared times by e to the minus 2t. I'm going to actually factorise that and simplify. So that's minus, no, let's just take e to the minus 2t out and take t squared out. We're going to end up with minus 2t plus 3 in our bracket there. Now we want to find a maximum or minimum, and you might be thinking, let's find dy by dx. We can certainly do that. We've got x is equal to 3t to the minus 1. dx by dt is equal to minus 3t to the minus 2. But I noticed that the mark scheme's not actually given any credit for that. And that's because we want to find the maximum or minimum. So this bit here will be on the numerator. So this will be, if I find dy by dx, okay, we've got our dx by dt on the bottom, which I've just worked out and crossed out, and we've got our dy by dt as e to the minus 2t, t squared minus 2t plus 3. So the thing is, unless something cancels, which it's not going to, dx by dt, nothing is going to simplify with the dx by dt. For dy by dx to be equal to 0, we would have e to the minus 2t, t squared. It's the numerator that needs to be 0. It doesn't really matter what the denominator is. So that's minus 2t plus 3 equals to 0. Now that gives us t equals 0, but note it's told us that t is greater than 0. So that's out. This can't be equal to 0 because it's the exponential function. It never becomes 0, or if you try and find the log of 0, it's a maths error. It's a bad way of mathematically explaining it. But anyway, it's never 0. whereas this bit is the thing that we need to look at. So we get our value for t. So we have minus 2t plus 3 equals to 0. So t is equal to 3 over 2. It wants the coordinate. It wants the coordinate there. So when t equals to 3 over 2, you can put x is equal to 3 over 3 over 2, which gives us x is equal to 2, and y is equal to 3 over 2 cubed, and e to the minus 2 times 3 over 2. That there becomes 27 over 8. And here we can see some cancelling goes on. And we have e to the minus 3. E to the minus 3. So the maximum point, so point P has coordinates 2, 27 over 8, e to the minus 3. Okay, so I'm just going to move that around so I can have space for the next part, which is involving parametric integration. So as I say, this is the one of the only times this has actually come up on the paper. So it's the Cartesian. We know that what's sometimes called, well, it is the fundamental theorem of calculus. If we're in Cartesian, this is our formula, BA, let's just say, and the limits are the higher value take away the lower value, if that's our y value, and then that gets us our area. If we're in parametrics, well, the formula changes, obviously, we're kind of changing the variable in a way. The y is there, but the dx bit we replace with dx by dt times dt. As I say, mathematically, infinitesimals and things don't cancel, but you can think of the dt kind of cancelling to give it this one here. So you kind of stick a dt on the bottom and dt on the top. Mathematically, there's more things going on. It's not really the story, but it's a way of kind of constructing the correct formula for us. But the important thing is here that some students miss out is the limits has to correspond to the following t limits for the x. These were limits of x here. That's the value of b is an x value, and the value a is an x value, the lower value. We need the values of t at those points, so we kind of need to do that, and we need to apply the formula. So let's work at the actual this bit first. Not too much of a problem for us. We've got y, which is t cubed e to the minus 2. Let's just do the dx by dt first, thinking about it. We've got x is equal to 3t to the minus 1. So dx by dt is equal to minus 3t to the minus 2. Okay, so we can stick that, we can put all these things in this formula. But in order to do that, we really need the limits for b and a. We need to work those out. So we've got b, and notice that's what the question says. Some people try to kind of avoid this issue. It says where a and b are constants to be determined. If it says determine, it means work them out and show how we've worked it. So we need to find the values of b and a in there. So when x equals to 1, which is our value of a, we have 1 is equal to 3 over t, a. So that's equal to, cross multiplying that, we get ta is equal to 3. And when x equals to 6, we've got 6 is equal to 3 over TA. So that gives us TB, because this is our value of B here, this is our value of A, so we've got a value of TB here and a value of TA here. So that gives us TB equals to a half. So now we should be able to put everything into this formula here, because we've got everything we need. But there is going to be a little catch to this, but which we'll see in a moment. Let's do the y. Y equals to t cubed e to the minus t, 2t. dx by dt is this, minus 3t squared. I'm going to bracket it, because otherwise it looks like I'm subtracting it, because I'm timesing by the negative of that. And that's dt. Which isn't exactly what we're getting there, but we're nearly there. Now here's a little bit of a catch though, as I've said already. We need to take care to put the corresponding t values in there. So the top one is the corresponding upper value for t, or the upper value for x, and the t value that corresponds to that. And that is TB, which is equal to a half. And then we've got the value of A, which is equal to 6. So that's slightly problematic, because we normally don't have, not 6 equals to 3. That's slightly problematic in that we don't normally have a situation where the upper limit and the lower limit are like the wrong way around, which we'll talk about in a minute. But let's sort the indices out first. So we've got those multiplied out. I'm going to stick the minus into front now. So we've got minus 3. And then we have t cubed times e to the times t to the minus 2. Just reordering it basically. So that gives it, these two combined to just give us t. These two combined to just give us t here. So that comes to t, let's put the limits in this again. So that equals to a half 3 minus 3 t e to the minus 2t dt. Now, what I found in class is most students, and if they got this far, so it's normally doing pretty okay to get this far, but most people then fudged it and just pretended the negative wasn't there. But we've got to really kind of use the fact that if we're swapping the limits around of a function, if we swap the limits around, we can do that, because if you think about it, that's whatever FB minus FA is. So you're taking one thing from another if you're integrating. So what we can do is, it's just the other way around, is just say that's minus fx dx with the limits swapped over. So that equals to, we can swap the limits around, and that's in any area of maths. If that happens, it's not often it happens, but if that happens, I can think parametric integration is the most likely time it would happen. But integration by substitution, it can happen as well. If that happens, then you can change your sign and reverse the limits, and then you're ready to go. So that's part B done. And then we're going to do some integration by parts. So I'm going to tidy up again, and then we'll get on with part C. Now part C is to integrate this. Now they haven't told us, they're not going to, because it's a clear case of integration by parts. Because if we ever have like an algebraic bit and something else going on, exponential trig, that's the kind of classic time when integration by parts is used, because none of our substitution won't work. Is if you've got different type of functions, sines and trig and a power of t would be similar, or something like that. So it's integration by parts, and we have a formula for that which we're given, and the integration by parts formula is given in the formulae at the front of the paper, which is integral of u dv by dx. I know we've got t's here, but it shouldn't bother us too much, times by dx is equal to uv minus the integral of v du by dx. So that's given dx. That's given to us. Now, unless we have a log, an ln, we not always, on this course we do anyway, we always let the actual power, the algebraic bit, be equal to the u. So we're going to let u equals to 3t, and we're going to let dv by dt, or dv, equal to e to the minus 2t. So we need to differentiate and integrate these bits. So differentiating u, you get du by dt is equal to 3. And integrating this, you get v. We're going the other way around, so if we were differentiating, we'd be timesing by the minus 2, but we're dividing by the minus 2 if we're integrating. And of course, because we'll put it into a formula which itself will have a constant, we don't put any constants in at this stage. I'm not going to worry about limits at the moment. I'll put the limits in later because we've got a little bit to do. So my first thing won't have limits in, and I'll just put limits in afterwards. So we're going to put things into this formula. So we've got the integral of 3t e to the minus 2t dt equals to uv, so that's these two multiplied together. So that's 3 times minus a half, 3t, sorry, times by minus a half e to the minus 2t times by v du by dx. So that's these two multiplied. So that's minus the integral of those multiplied. So that's 3 times minus a half e to the minus 2t. Now with integration by parts, with trig or with an exponent, we often have this kind of issue with double negatives and things. I do like to tidy up as we go along, not have like 3 or 4 negatives even in my expression. And so let's tidy that up. I'm not going to integrate at this stage, but I will tidy this bit up as well. So that bit there, because I'm just multiplying things out, is just minus 3 over 2 t e to the minus 2t. And this bit, the two negatives I can take out. I can just do plus 3 over 2, because I've got two negatives there, e to the minus 2t dt. Okay, this, by the way, by this stage we are up to 2 of the 5 marks. If you're interested in how the mark scheme goes, you can put a C on at this stage. They're going to be probably generous because they know you're going to put limits in afterwards, so you can get away with it because we know there's going to be limits in at the final reckoning. But let's do the integration then. I'm still not putting limits in at this stage, but I could do, but I'm not at this stage either. I'm just going to integrate this bit. Minus 3 over 2t e to the minus 2t. And integrating this, it's now going to be another negative, and I'm dividing by 2. So that's minus a quarter, minus 3 over 4 e to the minus 2t. Again, plus c if we if we want to be pedantic. But we're going to put we're going to put limits into that. So let's just do the final bit. I'm just going to make a bit more space for myself and then get on with it. So, by the way, we're now actually up to 3 marks out of 5, but we've got to put the limits in to get the final answer. So the area R is equal to the integral with the limits on it now. So is equal to the integral which we've worked out, which was this, which was all the way down in the last question. We worked the limits out to be 3½ on the bottom, times 3t e to the minus 2t dt. That's just writing out the question again. I think it's nice for presentational purposes, but we now have integrated this and found it that we definitely don't need the constant now because it's definite integration. There was no pun intended there, by the way. Definite was just a kind of normal English language meaning definite. So that's e to the minus 2t from 3 to 1/2. Okay, so I'm going to just put the limits in. So that's equal to minus 3/2 times 3 e to the minus 2 times 3 minus 3/4 e to the minus 2 times 3. Take away the limit with half in it. So that's minus 3/2 times 1/2 e to the minus 2t, 2 times 1/2, which is that there. And then minus 3/4 e to the minus 2 times by 1/2. Right, so I'm just going to do these individual bits. So this bit here, that will come to minus 9/2 e to the minus 6. And this bit here, that's obviously the 3/4 is already simplified. So we've got that minus 3/4 e to the minus 6. Take away this bit here is bracket minus 3/4 e to the minus 1, because 2 times minus half, and this is also minus 3/4 here, this bit. So these two together simplify, and that's going to be minus 18 and minus 3, so that's minus 21/4 e to the minus 6. And this here, we're going to have those two combined to give us 3/2, but it's negative 3/2, but it's positive, so that's plus 3/2 e to the minus 1. So no, that's exact. So that's it. We've got through the whole question. Reasonably long question. 5 marks for the last bit. So it's 9, 12 marks. And yeah, that's it. Hope it was useful. Bye.